All right, our last lesson for volume deals with finding the volume of solids. So instead of just one shape, some shapes that are smushed together or some irregular shapes or some shaded regions. And then also some word problems, figuring out how to use volume in word problems. So the first three problems are a lot like the area and perimeter ones we did before, where you're adding shapes together, you're subtracting shapes out. The more careful you are and the more work you show, the better off you're gonna be. Because you can find individual volumes very easily. It's just doing the correct math in between the volumes to get the final answer. So if we find the volume of this first solid, hopefully you recognize that it's two different rectangular prisms. We have this one here on the left, and then we have this one here on the right. So we just need to find the volume of each one and then add them together. So this pink peachy one, if it's a rectangular prism, our volume formula is capital B times H, or length times width times height. Hopefully by this point you're getting pretty good with these, that you pretty much just end up multiplying the three numbers together. I have my length, my width, if you can't see it right away, is actually gonna be 5. You might think, well, I don't want to include this extra piece, but really you're just saying that this piece that's hidden behind the shape here is gonna be 5. So length times width times height. So I'm taking 8 times 5 times 3. So the volume of that first shape is going to be 8 times 5 times 3, which is 120 cubic centimeters. So that's part 1. Part 2 is this blue shape. Again, we have the same formulas, either capital B times H, or the area of the base times H, or length times width times height. Again, hopefully you're recognizing all you're doing is multiplying the three dimensions together. You're taking length times width times height. So 2 times 5 times 6, which ends up being 60 cubic centimeters. The last thing you need to do is just total those together. So I'm taking this one plus this one, and I end up getting 180 cubic centimeters as my answer. In the next one, we're finding the volume of a solid. It's kind of like those shaded region problems. So the volume we're finding is actually this gray square or cube or rectangular prism with that center piece cut out. It's just showing us what the inside looks like. So hopefully looking at this, you can recognize we're gonna have to take the volume of that prism and subtract out the volume of that cone. So if I wanna find the volume of that prism, I'll do that down here. Hopefully we're feeling good about that. Again, we know it's base times height, or length times width times height. So if I'm looking at that, I can see that I'm going to have a square as my base. So these sides are all going to be the same, and I'm giving you that as information if you didn't know that off the start. So my base is a square, so I have 5 and 5 and 5 and 5. So if I'm taking the volume of that shape, I'm taking 5 length times width, and be really careful because the whole height is actually 7. This is giving me the height of that cone. So 5 times 5 times 7. And that comes out to be 175 for that first half. Now then, if I take the volume of this cone, check to your formula sheet, a volume of a cone is 1/3 pi r squared h. So when I look at it, we need to be really careful because it's 1/3 in pi. Your r, you might put as 3, but it's actually half of that. It's 1.5. And my height of just the cone, if you look across here, is 5. So I'm taking 1/3 times pi times 1.5 squared times 5. Again, 1/3 times pi times 1.5 squared times 5, and I end up getting 11.78, so I'll say 11.8 for that volume. Now the tricky part here is remembering that you're used to adding, but this this cone was actually cut out of this prism. So we want to take 175 minus 11.8 and get an answer of 163.2 centimeters cubed. All right, the very last one like this, before I start another video here, is to find the volume of the solid. And you can see again, it's just two shapes mushed together. I have a prism on the bottom, which is good news. Those are easy, rectangular prisms. And the top, hopefully you recognize, is a triangular prism. So we're gonna have to take the volume of two prisms. So let's start with the easier part, the rectangular prism. We've done this a lot through these notes already. So I'm taking length times width times height, or the area of my base times the height. So it's 5 times 8 times 6, which comes out to be 240 centimeters cubed. Part one's done. Now my second part is also a triangular prism, and remember I said these are the ones that really trick people the most. If I'm finding the area of my base, I'm just gonna put it in a little bubble down here. Remember, my base is a triangle right now, so I'm taking 1/2 base times height. If I look at this triangle, the base is this whole piece here, which is 8. So 1/2 times 8. My height is the height of that triangle. Remember, I'm not talking about the height of the whole shape yet. I'm just finding the area, the two-dimensional area of the base. So my base is 8, my height is this little 4 right here. So my capital B value for this problem is actually just 16.